Hello everyone, welcome to today's session. I'm excited to introduce our first chapter. Today we will explore matter in our surroundings. This is for Class 9 students, brought to you by Bardwedge Classes. In this presentation, we'll cover what matter is, its different states, and some interesting properties. So let's get started and discover the fascinating world of matter around us. Now, let's explore the differences in the characteristics of the states of matter: solids, liquids, and gases. These differences are fundamental to understanding how matter behaves in various environments. First, solids have a fixed shape and volume. Their particles are tightly packed together, which gives them that rigid structure. Because of this, solids don't easily change shape or volume unless you apply a lot of force. Moving on to liquids, they have a fixed volume but take the shape of their container. This is because their particles are less tightly packed than in solids, allowing them to move around more freely. However, they still stay close enough to maintain a consistent volume. Gases are quite different. They have neither a fixed shape nor volume. They expand to fill whatever space is available, with particles that are spread far apart and move very quickly. This high level of particle movement explains why gases are easily compressible and can expand or contract depending on temperature and pressure. Connecting these points to our overall theme, understanding these differences helps us see how materials respond to different conditions, which is crucial in fields like engineering, chemistry, and even everyday life. Recognizing how particles behave in each state gives us insight into the nature of matter itself. All right, let's talk about packing in different states of matter. When we look at solids, the particles are packed very closely together. They are tightly arranged, which gives solids their definite shape and volume. Moving to liquids, the particles are still close, but not as tightly packed as in solids. This allows liquids to flow and take the shape of their container while maintaining a fixed volume. Now, in gases, the particles are much farther apart from each other. They have ample space to move around freely, which is why gases expand to fill whatever space they are in. Understanding these packing differences is key because they directly influence the physical properties of each state. For example, the density and compressibility of a substance depend on how tightly its particles are packed. So, by examining how particles are arranged in solids, liquids, and gases, we get a clearer picture of their behavior and characteristics. This concept is fundamental as we explore the physical properties of matter throughout this presentation. Let's talk about volume today, which is a key physical property. Solids, for example, have a definite volume, meaning they keep the same shape and size unless you change their shape physically. Liquids also have a definite volume, so they take up space, but they can flow and change shape to fit their container. Gases, on the other hand, do not have a definite volume. They will expand to fill whatever container they are in, occupying the entire space available. Understanding these differences in volume helps us see how different states of matter behave and interact in various environments. It's a fundamental concept that connects to the overall theme of physical properties and how matter exists around us. Now let's talk about the shape of different states of matter. Solids, as you might expect, have a definite shape. They keep their shape no matter what, which makes them quite stable. Liquids, on the other hand, do not have a fixed shape. Instead, they take the shape of whatever container they're in. So pour water into a glass or a bowl, and it will adapt to that shape. Gases are similar in that sense. They don't have a definite shape either. Gases will fill any container they're placed in, spreading out to assume the shape of that container. These differences in shape are key physical properties that help us understand and categorize matter. Recognizing whether a substance is a solid, liquid, or gas can tell us a lot about its behavior and how it interacts with its environment. This is an important part of understanding the physical properties that define different states of matter. Let's talk about density, which is a key physical property of matter. Solids have high density, meaning they are generally more compact and have more mass packed into a given volume. This is why solids are often hard and heavy compared to other states. Moving on to liquids, their density is less than that of solids, but still more than gases. So, liquids are somewhat less compact, which explains why they can flow and take the shape of their container. Finally, gases have the least density because their particles are spread far apart, making them much less compact than solids or liquids. Understanding these differences in density helps us grasp how different states of matter behave and interact in our world. Let's talk about diffusion and how it varies across different states of matter. Solids, as you might expect, have no tendency to diffuse. They are tightly packed, so their particles don't move around much, which means diffusion is practically non-existent. Moving on to liquids, they do diffuse, but quite slowly. Their particles are more loosely packed than in solids, allowing for some movement, but it's still relatively gradual. Now, gases are a different story entirely. They diffuse rapidly. Because their particles are far apart and move freely, gases spread out and mix much more quickly than solids or liquids. This variation in diffusion rates is a key physical property that helps us understand how substances behave in different states. It's especially important when considering processes like mixing, separation, or even how gases disperse in the atmosphere. So, in summary, diffusion is minimal in solids, slow in liquids, and rapid in gases, and these differences are fundamental to how materials interact and behave in our world. Let's talk about compressibility, which is a key physical property. When we look at solids, their compressibility is essentially negligible, meaning they don't change volume much under pressure. That's because their particles are tightly packed together. Moving on to liquids, their compressibility is very low as well, but slightly more than solids. Their particles are close, but there's still some room for slight compression. Now, gases are a different story entirely. They have high compressibility because their particles are spread far apart, allowing their volume to be easily reduced when pressure is applied. Understanding these differences is important because it helps us grasp how different materials respond to pressure, a critical aspect in many applications. Solids resist compression, liquids resist it slightly, and gases can be compressed significantly. This variation ties into the overall theme of physical properties and how they influence the behavior of materials in different environments. Let's take a closer look at the intermolecular forces of attraction and how they differ across states of matter. In solids, these forces are at their maximum, which is why solids tend to have a fixed shape and volume. The molecules are tightly packed together, held in place by strong attractions. Moving to liquids, these forces are less than in solids, allowing molecules to move around each other more freely, which explains why liquids can flow and take the shape of their container but still maintain a fixed volume. Finally, in gases, these forces are negligible. The molecules are spread far apart, moving independently, which gives gases the ability to expand and fill any space available. Understanding these differences in intermolecular forces helps us grasp why each state of matter behaves the way it does, fitting into the larger picture of physical properties. Let's talk about the kinetic energy of molecules now. In solids, molecules have the least amount of kinetic energy because they are tightly packed and mostly just vibrate in place. When we move to liquids, the molecules have more kinetic energy, which allows them to move around each other more freely, giving liquids their fluidity. And in gases, molecules possess very high kinetic energy, moving rapidly and randomly, which explains why gases can expand and fill any space. So, as we go from solids to gases, the kinetic energy of molecules increases significantly, and this change in energy is key to understanding their physical properties. Thank you so much for watching. I really appreciate your time and attention throughout this presentation. I hope you found the information helpful and engaging. Remember, the key points we discussed, whether it's the importance of innovation, teamwork, or strategic planning, all tie back to our overall goal of continuous growth and improvement. If you take away anything, I hope it's that embracing change and staying adaptable are crucial in today's fast-paced environment. Again, thank you for being so engaged. I look forward to seeing how you apply these ideas moving forward.